Okay, onto this pretty difficult passage 3. For this one, I'm going to show you the way that I would do it. Not necessarily the way I expect a Band 7 student to do it, but it's good for you to see how I would do it so that you can see what kind of advanced exam skills and reading skills you need to have if you want to push your score into Band 7 plus Band 8 territory. If you want to get those high scores, you've got to do well in passage 3. So this is how I would do this paper. Right, when evolution runs backwards, I would quickly go and check what's happening. Of course, multiple choice, one of these matching sentences, and a yes, no, not given. Now, all three of these I know are going to be difficult. Doesn't actually matter which one you start with, they're all going to be difficult. But I do immediately see something over here, so I think I might as well just start there. Remember, passage 3, you're going to do a lot more reading than in the other passages, and your reading skills are very important. So yes, we're using these passage 1, passage 2 skills, finding keywords, but they're only going to help us a little bit. What else have we got? Embryos, evolutionary throwbacks, don't know what that is. Womb, that's a unique word. So it's probably going to be, Wagner is the name. Probably going to be somewhere toward the end, not necessarily, but I'll start checking from the end. I'll start checking around here, and I'm looking for that name Wagner and South America, and I see Wagner there, South America's there. What else did we need? Wagner Bacchia lizards, embryos. There we go. Embryos, embryos, embryos. Notice this sort of thing. There's embryos, and I actually see womb there as well. Maybe we can come to that later. Alright, good. So it's enough for me. I'm going to start with that now. Wagner was the first person, that's probably our target language, to do research on South American lizards. So in a paper published last year, this says it's the first time they mentioned him. They tell you who he is. Reported some work on the history of these lizards. Many of these, I'm looking for something about he was the first person to do it. According to his analysis, nothing. So I'm quite confident that's going to be not given. It doesn't say anything that he was the first. It's quite an easy one actually. Wagner believes that Bacchia lizards with... What? Wagner believes that Bacchia lizards with toes had toeless ancestors. So Bacchia lizards with toes had ancestors without toes. Right, Bacchia lizards. We want Wagner believes. So what is his conclusion? Wagner believes. These all follow the same pattern. They introduce the guy, they explain what he did, and then they say what his conclusion is. The simplest explanation is that they never lost their toes, but Wagner begs to differ. He differs. He doesn't think so. This is, according to his analysis, this is what he believes. The toad species re-evolved toes from toeless ancestors. And what is more, I think that's all that we need. The toad species of this lizard re-evolved toes from toeless ancestors. So their ancestors were toeless, didn't have toes, and then these ones grew toes again. Believes that lizards with toes had toeless ancestors, yes. Great. Temporary occurrence of long-lost traits in embryos is rare. Target language. Is it rare or is it common? Temporary. Temporary might be a keyword. Temporary occurrence of long-lost traits in embryos is rare. I didn't see anything here about embryos, 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 embryos. Nothing. Here's embryos. Early embryos of many species develop ancestral features. Ancestral features, I think, is long-lost traits. Features, traits is the same. Ancestral, from your ancestors, long-lost. Temporary occurrence of long-lost traits in embryos is rare. I think it's yes, but I'm going to skip it. I want to move on. Snake embryos, for example, blah, 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 blah. Late in development, these features disappear. Okay, I'll come back to that. Evolutionary throwbacks might be caused, might be target language, might be caused by developmental problems in the womb. Now that's strange because womb is over here. I don't see womb. Maybe later in development, these features disappear. thanks to developmental programs, not problems, that say lose the leg. Okay, actually, this is getting very complicated. I'm going to have to come back to that if I have time. See, these are quite difficult. I don't understand what they're talking about. Right, what am I going to do next? Let's take a look at these. Let's look at some keywords. For a long time, that's quite interesting because that tells me they're talking about history. That's probably going to be somewhere at the beginning. For a long time. Opposing views on evolutionary throwbacks. Evolutionary throwbacks is there as well. Evolutionary throwbacks. Examples. Now this is, so the evolutionary throwbacks is quite a common term. Shark and killer whale I remember seeing, and Wagner again. Okay, a couple of things I can do there. Maybe I'll go and see what Wagner says, the explanation. I did see shark and killer whale, but I also want to know what is this. It's obviously a very important term for this reading, so maybe I'll even go and find it now because it might help me with this one. What is evolutionary throwbacks? And now you just got to kind of scan for evolutionary throwback, but we get quite lucky and we see it right there. Now, this is where reading skills come in more than passage 1 and passage 2. We need to find out what is this. The description of any animal as an evolutionary throwback is controversial. Evolution runs backwards. For the better, most biologists have been, I saw biologists over here, biologists rejected, I see that immediately, have been reluctant to use those words. Biologists don't want to use these words because of principles of evolution. That says evolution cannot run backwards. So an evolutionary throwback is exactly this, when evolution goes backwards. But as more and more examples come to light, blah, 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 the principle is having to be written. Not only are evolutionary throwbacks possible, they sometimes play an important role in the forward march of evolution. Okay, interesting. So an evolutionary throwback is when evolution goes backwards. So an animal slowly loses its toes and then subsequent ancestors grow toes again. So evolution is going backwards. But actually, I want to focus on this. For the better part of a century, most biologists have been reluctant to use the word evolutionary throwback because of principle of evolution that says evolution cannot run backwards. Reluctant means they don't want to do it. They don't want to talk about evolutionary throwback. And I saw that over here for a long time. That was for the better part of a century. Biologists rejected, they have been reluctant to use. What did they reject? The use of this word evolutionary throwback, or the idea. The question of how could reappear, maybe. The occurrence, maybe. No. Rejected, no. They didn't reject the doubts. This is what they rejected. The possibility of evolution being reversible. The idea. They're reluctant because of the idea that evolution cannot run backwards. Backwards, reversible. So they rejected this idea that evolution can run backwards. So I'm quite confident to go with this one over here. You see, what I'm doing is I'm jumping around a lot. And this is a advanced exam skills. Is you take whatever you get when you can see it. So anyway, I think I was busy with Wagner. One explanation for the findings of Wagner's research is, so an explanation, so that's obviously going to come after all of this stuff about Wagner. According to his analysis, here's an explanation, but here's more explanations. So let's read from here. The toad species re-evolved toes from toeless ancestors, and digit loss, digit is toes, and gain has occurred on more than one occasion. So all that he's saying, that's not an explanation, that's his reporting his findings, that's his analysis. What's going on? One possibility is that, okay, this is very important language. I've spoken about this sort of thing before when they say 3 factors or 2 possibilities or whatever, go and find them. One possibility is that, and where is it? Another more intriguing possibility is that. Are there any more? No. So there's 2 possibilities for two explanations for his theory over here. What are the two explanations? One, these traits are lost and then they simply reappear in the same way that similar structures can arise in unrelated species, such as dorsal sharks and killer whales. I'll come back to that later. So what is important here? What is the explanation? They simply reappear. What is the other explanation? The genetic information survived and was reactivated. So one is these traits, these features, these characteristics are lost and then reappear. Another one is that the information survived and then was reactivated. So which one of those two is this? The question of how know the occurrence of a particular feature, maybe, because we're talking about, no, you can't say the explanation is the occurrence. This was the different species. This was the sharks and killer whales, unrelated species. So maybe it's that one, but I want to keep on reading. Parallels. One explanation for the findings of Wagner's research is the continued existence of certain genetic information. Yes, genetic information. Doubts, that one's gone, and nothing about these two. So it's either this one or this one. Occurrence. An explanation is the occurrence. But here, this is not an explanation. This is just an example of the explanation. The explanation is here and the explanation is here. Those are the two explanations. So this is an example of that explanation. It's not really that, but this one talks about the genetic information continues to exist, somehow survived for tens or perhaps thousands of years, millions of years, continues to exist. So I'm going to go with that one. The continued existence of certain genetic information. D. All right. What else have we got? Let's do the shark and killer whales. The shark and killer whale are mentioned to exemplify, to be an example of. To be an example of what? Actually, it's all this here. Such as is the example of what? It's an example of that. So the sharks and killer whales are an example of the way that similar structures can independently arise in unrelated species. And I know where unrelated species is. Occurrence of a particular feature, similar structures in unrelated species. So the shark and killer whale are mentioned as an example of B. The occurrence of a particular feature in similar species. Similar structures can independently arise in unrelated species. Right, B. Now, I need to decide, am I going to continue with these two or go and start looking at the multiple choice? Opposing views on evolutionary throwbacks are represented by, I don't see anything. Examples of evolutionary throwbacks have led to, I can't see anything. Let's see if we can find our way around. Maybe those, I must remember though, opposing views and examples might come up later. Right, let's look at some multiple choice. When discussing the theory developed by Louis Dollo, the writer says that. Scan, 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 scan. There's Lombroso, there's a name. And there's Louis Dollo, right. What does he say? It's the first time it's mentioned. While Lombroso was measuring criminals, this is Lombroso over here, was studying fossil records and coming to the opposite conclusion. And he proposed, why does the writer talk about, the writer says that when discussing the theory, okay, so where does he discuss the theory? Here's the theory. Here is the writer discussing the theory. Early 20th century biologists came to a similar conclusion, though they qualified it in terms of probability, stating this is what the biologist stated: there is no reason why I cannot run backwards, it's unlikely. And so the idea of irreversible stuck and came to be known as. Alright. It was immediately referred to as Dollo's law. No. It came to be known as Dollo's law. This is even after the 20th century. So he proposed it in 1890. It wasn't immediately, no. It supported the possibility of evolutionary throwbacks. What did Dollo's theory say? Here's the theory. An organism is unable to return partially to a previous stage. So he says cannot do evolutionary throwbacks. Unable. So not that one. It was modified by biologists in the early 20th century. Yes, the biologists did it in the early 20th century, and then they qualified, modified it in terms of probability. So they modified the theory. So I would say yes, and just check, based on many years of research, no, I didn't see anything about that. So yes, that's enough for me. Right, Vancouver Island, humpback whale. So we're over here, scan, humpback whale, Vancouver Island in Canada. So what do we need to know? Humpback whale is mentioned because of, why does he mention this humpback whale? For example, if Dollar's law is right, these, I don't know what that is, should occur only very rarely, if at all. Yet almost since the idea took root, exceptions, I think, as an example of an exception maybe. Exceptional size, that's a different use. They've used a different use to try and confuse you. Exemplifies Dollar's, no, it's an exception to Dollar's law. The amount of local controversy, no. The reason given for its unusual features. What was the reason given for its unusual features? The idea, no. Argued at the time. Must be, there's the reason. The reason, I can see no other explanation. There's no other reason except that the whale must be an evolutionary throwback. Okay, very tough. I would have to, that one I actually thought I'll go with this one mainly because the other three aren't really there. Right. What is said about silent genes? Silent genes. Don't see it. There's silent genes over there. If these silent genes are somehow switched back on, long lost traits could reappear. These silent genes, so they reason that while some evolutionary changes involve the loss of genes and are irreversible, others may be the result of genes being switched off. Their numbers, no. I don't know what Raf said. Yes, no. They could lead to the re-emergence of certain characteristics. Long lost traits could reappear. Re-emergence, long lost traits, characteristics. Alright, so that's fine. Now we're going to start running out of time really, and we have to start guessing. Actually, I see one about Wagner here, so we know him. Which of the following does he claim? Members of the lizard family have lost and regained certain features several times. Yes, I remember that. Evolution is due to the environment. No. I don't know about Raf. Other species, no. I feel good about that. Let's just check that. Lost and regained certain features several times. According to his analysis, the toad species re-evolved from toeless, and what is more, digit loss and gain has occurred on more than one occasion. So I'm happy with that. That means the same thing. Maybe I should have even done that first. I didn't see Wagner. Should have gone there straight away first. So we've got one of these left and two of these left. So we just got to go and look at these two yes, no, not givens, see if we can knock them out quickly. The temporary occurrence of long lost traits in embryos is rare. But if silent genes degrade within 6 million years, how can long lost traits be reactivated over longer time scales? The answer may lie in the womb. Early embryos of many species develop ancestral features. For example, later in development, these features disappear. So that's the temporary occurrence. They appear in the womb. The womb is the chamber inside the mother's stomach where the baby grows. So they appear in the womb and then they disappear. But the key word here is many. It happens often. It happens with a lot of species. It is not rare. So that was the target language, and that's definitely no. Evolutionary throwbacks might be caused by developmental problems in the womb. And I actually said not given for this. And the answer that IELTS gives is yes. So they say yes, evolutionary throwbacks might be caused by developmental problems in the womb. Yes. I said not given because there's nothing here about problems. They don't say that this is a problem. They say something about developmental programs, but all they say is that these things appear and then they disappear. They don't say that it's because of a developmental problem. So I'm actually going to stick to what I said. I believe that this is not given because there's nothing there about developmental problems. But look, IELTS says, yes, it is because of developmental problems. But I'm going to say I disagree. It's not given. There's nothing there about problems. All right. Let's try and look somewhere where we haven't looked. Opposing views represented by, and examples of evolutionary throwback. I think I'm going to go and look up here because we haven't used these paragraphs here. And you just got to read. So this guy argued that criminals were born, not made. Features that were throwbacks. So we were looking for people's viewpoints. There's Lombroso, there's Dollo, and he came to the opposite conclusion. So these are the two opposing viewpoints. And I remember I saw two names down here, Dollo and Lombroso. These are two opposing views. 33, that's fine, G. Alright, so I've actually run out of time now, and I would just have to take a guess for a couple of these other two. So I'll just show you where they are, but don't worry if you don't get all of them. But that's how you can get about 10 out of 13 for this passage. Examples have led to, examples of throwbacks have led to what? Question of how could reappear, parallels between that, no doubts about that. I would have said A. You're kind of guessing, because that's what this whole passage is about though. And it's actually over here. Examples have been reported that break the time limit, suggesting that silent genes may not be the whole story. And so what's going on? So that's the question of how these could reappear. What's going on? Very difficult. Don't worry if you didn't get that one. I think I wouldn't have seen that one. I just guessed it as A because there weren't any others left. And then this one we're also going to guess. The mole salamander. It's after silent genes. Where's mole salamander? Somewhere. RAF genes, silent genes. There's mole salamander. And what are we looking for? The writer, why does he mention them? Raf's theory is correct. Lost and regained. Why does he mention them? Often you have to look before. Why is he mentioning it? Because of something that he said before. In other words, throwbacks are possible, but only in the relatively recent evolutionary past. And what is this all about? This is all about Raf's team and what they did and what they found. So therefore they found that things are possible. And then he, as an example of that, so the reason he mentions it is to suggest that the theory is correct. That previous paragraph was all about Raf's theory. For example, mole salamander. Just check these. Exemplifiers, no. Lost and regain more than one ability, no. Subject, no. So yes, I would go with that. But I would have probably had to guess that one. Anyway, yes, I don't know if I would have gotten full marks for that in 20 minutes, to tell you the truth. It was very difficult, but I just wanted to do this video a little bit differently to show you how I would do it and the kind of advanced exam skills that you need to get a high score in this passage 3. All right, good. I hope that helped. Thank you very much.